In the last segment, I introduced scientific notation as a way of managing very large numbers and very small numbers in an efficient way. So we started with the first one, 4.12 times 10 to the third. 4 is in the ones place, so yes, that is in scientific notation. Also, do note that you'll need to know how to expand it because your job is to recognize that this value and this value are the same. It's just that this one is in scientific notation. This value over here is not in scientific notation. It is in expanded form. But we can put it into scientific notation and maintain our significant figures by writing 2.994 times 10 to the minus 1, 2, 3. I basically move the decimal 3 places to get the 2.994. Remember, negative powers of 10 are small numbers, positive powers of 10 are big numbers if it's confusing. Sometimes you get a number like this that looks like it's in scientific notation, but it's not because the 7 is in the hundreds place, which means there's 2 more powers of 10 we can factor out of there. So going forward, we fix it by taking 2 powers of 10 out, making this value 2 powers of 10 smaller, 7.98, and make this value 2 powers of 10 bigger. Okay, now if we expand it, this is a negative power of 10, so this would be 0.1234798. And if you want to check, which you should, move the decimal 1, 2, 3, 4, 5 places to get your 7.98 back. 5 places here, 5 places there. Page 10. More examples if we need it. 18,742, for example, is not in scientific notation. So we would say 1.8742 times 10 to the 1, 2, 3, 4. Now I might ask you to round, for example, to 2 digits or 2 sig figs. That would be 1.9 times 10 to the 4th, or 19,000. Again, your job, in addition to being able to move from scientific notation to expand it and back again, is part of what you need to do. You need to recognize the different values that show up on your calculator. Now, back to our maneuvering between English and SI metric. Over time, the same powers of 10 seem to keep showing up, not entirely unlike $1 bills, $10 bills, $100 bills if you're lucky. So you need to look at these common prefixes and know how to use them. So committing them to memory is only part of the deal. Now you're going to need to find these in your textbook and you're going to need to commit them to memory. So I will show you in class which ones you need to know. However, for the sake of illustration, I will demonstrate a few of them for these lecture notes. Kilo, symbol little k, not to be confused with big K, Kelvin, or other Ks that we're going to see throughout the semester. Kilo means 1,000, so 1 kilo whatever equals 1,000 whatevers. So I could say 1 kilo box equals 1,000 boxes, or I could say 1 kilogram equals 1,000 grams, or I could say 1 kilometer equals 1,000 meters. And just like I did on the other page with the English equalities, equality means something equals something. We can derive those into conversion factors and take the reciprocal. So what we get out of, for example, our generic one is 1 kilo whatever over 1,000 whatevers, or 1,000 whatevers over 1 kilo whatever. Okay? So you can fill in whatever unit you want, but that's the ratio that is numerically equal to 1, and both of these are going to be conversion factors. Okay? Centi, little c, means 1/100th. So 1 centi whatever equals 1/100th of a whatever. And this, it can be confusing. Okay, so multiply both sides by 100 to say that 100 centi whatevers equals 1 whole whatever. And so you can put in whatever unit you want. 100 centimeters equals 1 meter. 100 centigrams equals 1 gram. 100 centicuries equals 1 curie. It doesn't matter if you don't recognize the symbol. And every single one of these can be reworked into 2 conversion factors just like we did up here. 100 centi, fill in the box, over 1. Or 1 whatever, 100 centi whatevers. You need to practice filling in the actual units and being able to derive these conversion factors, because you have to be able to use them to convert. All of these are conversion factors that you should have done in your basic class. What we're doing is we're expanding the list. So the list will be longer than perhaps what you did in your beginning class. Okay? Mega. Mega, capital M, not to be confused with milli or meter or molarity or other places where you see capital M. Mega means 1 million or 10 to the 6th. So 1 mega, whatever your unit is, equals 1 million of that unit. 1 megabyte equals 1 million bytes, for example, in the olden days when we didn't have giga. Okay, so you can do the same thing that you've done up here, and you can come up with your conversion factors. 1 megabyte over 1 million bytes, or 1 million bytes over 1 megabyte. Or again, just have some kind of box to indicate whether it's a byte or a gram or a curie or a rem or a milliram or whatever it is that you're using. Okay, next page. We'll do one more quickly in this segment. Nano, little n, 1/1 billionth, very, very small. Again, this is a negative power of 10, and this can be confusing. So if we multiply both sides by 1 billion, these cancel. 1 billion nano whatevers equals 1 whole whatever. And put in whatever unit that you want. Okay? 1 billion nanograms equals 1 gram. Okay? Whatever unit you want. And then from the equality, you get your 2 conversion factors. Okay? Now try this with all the others that are in your book. There should be a list of these on Blackboard for you. You must know the symbols, but you also have to know how to use them, because what we're going to do next is we're going to work on using these to convert.